An incremental backup is one that provides a backup of files that have changed or are new since the last incremental backup. It is one that backs up only the data that changed since the last backup, be it a full or incremental backup. An incremental backup is a backup of latest changes since the last backup, so that when a full recovery is needed, the restoration process would need the last full backup plus all the incremental backups until the point in time of the restoration. Incremental backups are often desirable as they consume minimum storage space and are quicker to perform than differential backups. The purpose of an incremental backup is to preserve and protect data by creating copies that are based on the differences in those data and thus minimize the amount of time needed to perform the backup. With incremental backups, successive copies of the data contain only that portion that has changed since the preceding backup copy was made. Variants: incremental, the most basic. A Unix example would be the use of RSYNCs. Linked list option is what makes this command an example of incremental backup. Multi-level incremental, a more sophisticated incremental backup scheme involves multiple numbered backup levels. A full backup is level 0. A level N backup will back up everything that has changed since the most recent level N1 backup. Suppose for instance that a level 0 backup was taken on a Sunday. A level 1 backup taken on Monday would include only changes made since Sunday. A level 2 backup taken on Tuesday would include only changes made since Monday. A level 3 backup taken on Wednesday would include only changes made since Tuesday. If a level 2 backup was taken on Thursday, it would include all changes made since Monday because Monday was the most recent level N1 backup. Reverse incremental, an incremental backup of the changes made between two instances of a mirror is called a reverse incremental. By applying a reverse incremental to a mirror, the result will be a previous version of the mirror. Incrementals forever, this style is similar to the synthetic backup concept. After an initial full backup, only the incremental backups are sent to a centralized backup server. This server keeps track of all the incrementals and sends the proper data back to the server during restores. This can be implemented by sending each incremental directly to tape as it is taken and then refactoring the tapes as necessary. If enough disk space is available, an online mirror can be maintained along with previous incremental changes so that the current or older versions of the systems being backed up can be restored. This is a suitable method in case of banking systems. Block-level incremental, this method backs up only the blocks within the file that changed. This requires a higher level of integration between the sender and receiver. Byte-level incremental, these backup technologies are similar to the block-level incremental backup method. However, the byte incremental backup method is based on a binary variation of the files compared to the previous backup, while the block-based technologies work with heavy changing units. The byte-based technologies work with the minimum unit, saving space when reflecting a change on a file. Another important difference is that they work independently on the file system. At the moment, these are the technologies that achieve the highest relative compression of the data, turning into a great advantage for the security copies carried out through the Internet. Other backup types: synthetic full backup. A synthetic backup is an alternative method of creating full backups. Instead of reading and backing up data directly from the disk, it will synthesize the data from the previous full backup and the periodic incremental backups. As only the incremental backups read data from the disk, these are the only files that need to be transferred during offsite replication. This greatly reduces the bandwidth needed for offsite replication. Differential. A differential backup is a cumulative backup of all changes made since the last full or normal backup. That is, the differences since the last full backup. The advantage to this is the quicker recovery time, requiring only a full backup and the last differential backup to restore the system. The disadvantage is that for each day elapsed since the last full backup, more data needs to be backed up, especially if a significant proportion of the data has changed. See also, backup rotation scheme, continuous data protection, delta encoding, dump, Unix utility for multi-level incremental file system backups. RSYNC, File Synchronization Algorithm and Protocol. References. Further reading.